Today we are going to be learning about area of regular polygons. The formula for the area of a regular polygon is A is equal to 1/2 a lowercase a and an uppercase p. In a minute, I will tell you what the lowercase a and the big P stands for. If you look over here, we have a hexagon. If I draw a circle around the hexagon, say here is the center of the hexagon. From here to each of the vertices of the hexagon are the radius of the circle. So all of these are radius. I'm going to mark it with 2 tick marks. All of these are the exact same length. Also, if it's a regular polygon, we know that all angles and all sides are congruent. So this side is congruent to this side. It's congruent to all of those sides. Now, looking right here, what I have is actually an isosceles triangle. So this creates 6 congruent isosceles triangles. If I look at this triangle right here, this angle right here is called the central angle. And the central angle is formed by 2 radii from the center to the vertices of the polygon. So central angle formed by 2 radii from the center of the vertices of the polygon. So right here is your central angle. All right, now if I drop down right here, I drop down a height that makes a right angle, which means that we have a right triangle. So I'm going to come over here and redraw this right triangle. So this right triangle right here is this right triangle. What we know so far from this right triangle. If you see here, this side, the hypotenuse, is the radius. So I'm going to label that the radius. Down here, if this is the side of the polygon, when we drop down the height with the isosceles, it makes 2 congruent segments. So this would be 1/2 the length of the side. This right here is going to be the letter A. It is called the apothem. So that's the next word, apothem. And what the apothem is, it is the segment from the center perpendicular to a side of the polygon. So that's what the apothem means. That's what the letter for A means. If we go back up to the formula, it says area is equal to 1/2 AP. So we know what A is. A stands for the apothem. It's this right here. P stands for the perimeter of the figure. Now, what we're going to do is create a chart. If you use this chart every single time you're trying to find area of a regular polygon, it will help you with the formula. So the things that we want to know: central angle. I want to know the half of the angle, the apothem, the A, the radius, 1/2 S, so half the side. S is the side. And then PER is going to be for perimeter. So once we know the side, the length of the side, we can find the perimeter. So if you draw this chart every single time when you're trying to find area of a regular polygon, it will help you organize your information and figure out what you need. All right, now let's go to the examples. Example 1. All right, so the first thing I'm going to do is draw the chart. So we have the central angle, 1/2 the angle, A, R, S. How I kind of remember this part, CARS. Well, if I have the angle, then after the angle would be half of the angle. And then if I have the side, I guess I did this in a slightly different order. I have 1/2 the side, and then the perimeter. So your order really doesn't matter as long as you have the information there. All right, so our formula, I'm going to write that down. A is equal to 1/2 A times P. Now, looking here, we have the triangle already laid out. The information that we know in this triangle, so I'm going to redraw it down here. So 9, here's my right angle. This right here, this is our A, 1/2 the side, and this is my radius. I sometimes always draw this triangle too with those letters, the A, the R, the 1/2 S, so I know what I need and where they go. So the 9 goes here. Back to my chart, I'm going to fill in the 9 for the A. Now, for the central angle, to find the central angle, it's 360 divided by the number of sides. Well, the number of sides here is 1, 2, 3, 4, 5, 6. So 360 divided by 6 is 60 degrees. Half of that angle is 30 degrees. So this angle right here is 30 degrees. That means what we have is a 30, this has to be 60, a 30, 60, 90 triangle. Now using 30, 60, 90, special right triangles. So 30, 60, 90. With the relationship with a 30 is our x, then x squared to 3 and 2x. Opposite the 60 is where the 9 goes. So now what we need to do is find what x and 2x is. Or first find what x is equal to. So coming down here, if I say x squared to 3 is equal to 9, to solve for x, we need to first divide by the square root of 3 on both sides. That cancels out, so we have x is equal to 9 square roots of 3. Now, in order to get rid of the square root in the denominator, to rationalize the denominator, we do not like having square roots in the denominator, we just multiply the numerator and the denominator by the square root of 3. Really, what we're doing is multiplying by 1 because square root of 3 divided by square root of 3 is 1. Remember, anything divided by itself is 1. So what we have over here, multiply the top. So this would be 9 squared roots of 3. And just for a little bit more extra work, square root of 3 times square root of 3, you multiply the inside numbers together. So 3 times 3 is 9. Well, we can simplify this, so the top would be 9 square root of 3 over, well, the square root of 9 is 3. You can do this if you want, or you can go straight to here. Now we still have to simplify. I can simplify 9 divided by 3, which is 3. So my x is 3 square roots of 3. Opposite the 30, then, this would be 3 square roots of 3. That is my 1/2 the side. So 3 square roots of 3 is half the side. If half the side is 3 square roots of 3, if I double that, it would be 6 square roots of 3. Now, continuing over here, the 2x, well, if x is 3 square roots of 3, then 2x would be 6 square roots of 3. Now we need our radius. Well, opposite the 90-degree angle here is the measurement of 6 square roots of 3. Now, the last piece of information that we need is the perimeter. Well, to find the perimeter, there are 6 sides, so we're going to 6 times the side length. So 6 times 6 square roots of 3, which is going to give us 36 square roots of 3. All right, now back to what we're really trying to find. The area of the hexagon. Area is equal to 1/2 AP. So my area is 1/2. Well, all you have to do is come and look up here in the chart. A is 9, and your perimeter is 36 square roots of 3. So now all we're going to do is multiply these together. 1/2 times 9 times 36. And when we do that, we get 162, and then the square root of 3. Now, don't forget, because we are talking about area, it has just the number 9. So area, we're just going to say units squared. Do not forget that at the end. So for example 1, your answer is 162 square root of 3 units squared. All right, now let's go to example 2. Like I said, the first thing that I always do is make the chart. I'm going to make it below this time. So central angle, 1/2 the angle, A, R, I'll do it in the order that we did it on the front. 1/2 the side, then the side, and the perimeter. Also remember our formula. A is equal to 1/2 AP. Now with this triangle, I'm going to come down here. Like I said, I like to redraw my right triangle. This is A, and here would be my right angle. This is going to be my A, R, and the 1/2 side. Now, central angle. Remember, to find your central angle, it's 360 divided by the number of sides. Well, 360 divided by 4 is 90. So half of the angle, so half of 90 is 45. That would be this angle right here. So if this says 45, this has to be 45 as well. So what we've got here is a 45, 45, 90 triangle. And that relationship, x square root of 2. Zoom in so we can see down here better. All right, what we know is we know that across the 90 is 8. So I'm going to